All right, guys. We're going to be looking at three things today. The first is deductive reasoning. Now, I'll read through this here. So, deductive reasoning uses facts, definitions, accepted properties, and laws of logic to form a logical argument. The difference from inductive reasoning, which uses specific examples and patterns to form a conjecture. So, what are we using with deductive? It is facts. We're using facts. Inductive is patterns, something that we can observe. Deductive is facts, definitions, accepted properties, and laws of logic, stuff that we can prove. Deductive reasoning is stuff that we can prove. Inductive reasoning is something that we see. Now, the two laws of logic that we'll look at are these two here. Law of detachment and law of syllogism. Law of detachment and law of syllogism. Now, the law of detachment states if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if the hypothesis is true, then the conclusion must be true also. And the law of syllogism is if P, then Q. If Q, then R. We're given two statements. If P, then Q. And if Q, then R. We can say, if these are both true, if P, then R. Because we have a hypothesis and conclusion that are the same in both, we can attach the other two. Let's go on and look at an example of this. So we're going to start off by using the law of detachment. Law of detachment. So our question is, if two segments have the same length, then they are congruent. Is that a true statement? Yes. Yeah, the hypothesis is true. Two segments have the same length. Means that they are congruent. So you know that BC is equal to XY. So we know the length of BC is equal to the length of XY, yes? Does that make the hypothesis of our conditional statement true if two segments have the same length? So BC equals XY makes the first part of that statement true, yes? So what's the second part? Then they are. So since we know that they are equal, they have the same length, it means what? That BC is congruent to XY. Because the law of detachment really states that if the hypothesis of the conditional statement is true, then its conclusion must be true also. Not always. We can't really say anything. Because it'd be a little hard on this one here. But there are others that won't tell us much. So if, let's see here. So if it is payday, then Johnny gets paid. If Johnny got paid, well, the hypothesis was what? If it is payday, then Johnny gets paid, yes? Do we know that it's payday? No. So we can't really say anything from it because Johnny could have sold a car and got paid that way. Yeah. Doesn't necessarily mean it's payday. Okay. So this other one here, because it told us the two segments are the same length, it made the hypothesis of the conditional statement true, then we can say its conclusion is also. But if they tell us like the conclusion is true, we can't go the other direction. Okay? Now, if possible, use the law of syllogism. Now, the main thing with this property is that we have a conclusion of one that is matching up with the hypothesis of the other. So when I look at this statement here, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Let's get a highlighter. Now, the main thing we just said, if with this property of syllogism, is that a hypothesis and a conclusion match up in the two statements. Is there one that matches up in both of these statements? X squared is greater than 25, yes? Is one of them the hypothesis and one of them the conclusion? Mm-hmm. So what's left over? Okay, so I want to write a new statement. Well, we have if and then, yes? Which one would go first? If x is greater than 5, then x squared is greater than 20. And the one other thing would be just making sure that it is true, that both statements are true, and they are. Because if x squared is greater than 25, then x squared has to be greater than 20. Because if I have a number squared that's greater than 25, so 6 squared is 36, yes? Is 36 also greater than 20? Well, yes. If x is greater than 5, then x squared is greater than 25. Well, that works too, because 5 squared is 25. So we do have two true statements. That means we can use it. And we also have this matching up, because we need both to be able to use it. Any questions on this here? Okay. Again, we're using the law of syllogism to write a new conditional statement that forms from the pair of two statements. If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. Does this work? We don't have a hypothesis and conclusion that are the same. Because both of them, the hypotheses do match up if a polygon is regular, But we don't have that matching of the two. So we can't really use the law of syllogism to actually write anything. It's not possible. Are these two statements true? Well, yes. Because if a polygon is regular, then all its angles in the interior are congruent. If a polygon is regular, then all of its sides are congruent. Those are two true statements, but we can't actually say anything from it. It's not possible. We can't do anything, because this here is not possible. Both statements are true, but I can't use this property to actually make a new conditional statement. Any questions on this so far? Any questions on anything we've done actually so far? We're pretty good with most of this here. Okay. Let's look at this next one, using inductive and deductive reasoning. What can you conclude about the product of an even integer and any other integer? Well, what are we using? Inductive or deductive? Because it could be one or the other. Do you have any facts about even and other integers? No? Do we have any idea what we could do to figure this out? How could I figure it out? With? I mean, we could try it because, I mean, there's no actual definitions here that we have. So the best thing we can do is actually try it. So 2 times 1 is 2. What's another one we can have? 3 times 4 is? Is? So what happens when we multiply an even integer and any other integer? What are these 3? They're even. Because no matter how we do this, 6 and negative 10, even if we do this here, it's going to be negative 60. The product of an even integer and any other integer will always be even. And here we had to use inductive reasoning to figure that out because we don't have any real facts about the product of even integers. So here we're having to use inductive reasoning for it. Questions on this here? So let n and m be integers and use deductive reasoning to show that the conjecture is true. Okay. So we use inductive reasoning to show that. Now we can use deductive reasoning also. Let n and m each be integers to show. Okay. So what do we know about the 2 integers? We have n. Okay. We do have n and we have m. Yes? And I do know that one of them is what? Even. So I can call it 2n. And we can say that their product, 2n, oh, that's not good. 2n times n would be 2n m, which is really just 2 times the product of n times m. So there's always going to be a factor of 2 making it even. What is it? 2n is an even integer because any integer multiplied by 2 is even. 2nm represents the product of an even integer and any other integer m. 2nm is the product of 2 times an integer nm, so 2nm is even. So it's another way that we can look at this actually using deductive reasoning. And just breaking it down using our properties of even integers. Decide whether inductive or deductive reasoning is used to reach the conclusion. Explain your reasoning. So let's look at this here. Each time Monica kicks a ball up into the air, it turns to the ground. So the next time Monica kicks a ball up into the air, it will return to the ground. Is this inductive or deductive reasoning? Why inductive? I agree that it's inductive, but why would we say inductive reasoning? What makes something or inductive reasoning and not deductive? Inductive is based off of what? Huh? It is dealing with hypothesis and conclusion, but what? There's one main difference between the two. Deductive is based off of what? Inductive is based off of a, what we can see, so it is a, starts with a P, pattern, because it's based off of a pattern, something that we can observe. And what is happening here, each time Monica kicks a ball up into the air, returns to the ground. Is that a fact? Because this is based off of a pattern. It's based off observations. But she's saying every time she kicks it up into the air, it returns to the ground. Each time I do this, it happens. This happens. So the next time Monica kicks the ball up into the air, it will return to the ground. We're seeing it's an observation. It is a pattern. It is inductive reasoning. Questions on this here? All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Why is it deductive? It's based off of facts. Yep. Questions on this here? That's it.